So whenever you are doing these kind of reactions, make sure that you write down the phases first. I know that reaction that's given to you already has the phases written down. So the phase for this is a solid, but this is all comes from that solubility chart we did before. And in fact, these same salts are the ones that were in the cards in the previous lesson. So you would have already had these figured out from before. AQ. All right. Something else that can be helpful is that if you know something's going to break apart ahead of time, because sometimes you get in the groove when you're writing it down. I like to kind of write where they're going to split, so the positive and the negative parts. And if you're not sure, go through your polyatomic ion list again. If you've forgotten your polyatomic ions, that shows you how the second part will group together if you have more than one little set of atoms in there. Now this one has a S, so that means it forms a solid and it doesn't break apart in water, so I kind of draw a circle around it. And then this one I split apart like that. The other thing to note is that when you split these things apart, they still have AQs, and you have to count up like the total number of ions. So this has 2 times 3. It's like saying that there's a total of 6 NAs in there, which there are. So, and I break it apart so that it's a positive, negative. If you're not sure on those too, you could also write those in ahead of time if that helps you. Over here, because that way maybe you're less likely to make an error. That's +2 right there. So 6 Na plus, and I'm going to write the AQs in at the end. The 2 also applies to the PO4. And then I have 3 Ca, 2 pluses. And the 3 also applies to the Cl. And there's a 2 there. I know, it feels annoying, right? This thing stays stuck together. That's why I put the big circle around it. And then this breaks apart into Na plus and Cl minus. Now I'm going to go through and write my AQs in there. Some people write it as they go along. It just kind of is however your brain works with this. And then that is called the full ionic because we haven't canceled anything out. This can be called the full equation, or sometimes people will call this molecular equation. Either way. And as a note, if you ever make a solid, that means your reaction is going to go. If you make a gas, the reaction is going to go. But if both things are AQ, then your reaction's probably not going to go because you need something to stick together to have a reaction happen. Now let's do the net ionic. And the net ionic tells you the equation that's really going on, like when you break it down into the things that are really the same. I also want to point out something over here. When I wrote this down, I wrote it a certain way to kind of show something to you. You can actually use the net to check your full ionic also, because there should be a match on both sides exactly. So like, see how that says 6 Na plus? If you look over here, I don't say 6 Na over there. Like, it has to be a perfect match. And you can usually catch an error that you might have made. If you look up, you might be like, oh, well, there's no 6 there. What's going on? Well, actually, this part was written down, and it wasn't written down completely balanced. There was actually a coefficient of 6 in the front there that I just didn't write down. But I thought it was a good point to make so that you can see that that helps you know that something's wrong, basically. So the things I'm highlighting, I'm going to highlight in different colors. Those things are what cancels on both sides. So when I get to my net, I'm just going to have the 2 PO4 minus AQ plus the 3 Ca2 plus AQ. And again, the Ca might be written first, and then the 2, we don't care which one you write first. It's just generally rewrite the positive thing first, but it really doesn't matter. And then that goes to Ca3 PO4 2. So this is the actual reaction that's going on. And then if we want to know spectators, we don't ever say how many spectators. They just want to know who is a spectator. So the stuff that's on both sides, that's what the spectator is. All right, let's move on to this one. And then here it's AQ, 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 and AQ. So since I have like both of these things are AQ, I can tell right off the bat there's going to be no reaction, and I can move on. If, however, I was told I had to find the full ionic equation for this, this is how I would do it. I'm going to go ahead and split it, tell how it's going to all split. This is a 2 minus, plus, minus, plus, minus, plus. You don't have to have done this as fast as I did. So then the 2, it goes in front. So 2K plus AQ. And again, you can wait on the AQs at the end. Just don't forget to do it. SO4, 2 minus AQ plus NA plus BR minus. And then we have K plus. And then we have BR minus. Then we have the 2 down there. It gets thrown in front. NA plus AQ. And SO4, 2 minus AQ. So that's the full ionic, full F. And then we'll look for things on both sides that are the same. So that's the same, that's the same. And again, it should be a perfect match on both sides for whatever you find. NA, NA. And then finally, BR and BR. So you can see that everything has a match, and so it cancels. And that's why the net, it has no net reaction. And everything is a spectator. Because they aren't really spectating if you think about it. There is no reaction, so they're not really watching. But I'm just saying everything is there's nothing participating.